That's fantastic.
It is.
I'm very happy for you.
Thank you.
Thankful to become someone like that.
All right, let's go over lines of best fit. Do you remember back in maybe Math 9? I'm not sure. When you would graph, what's a line of best fit? It's literally what?
The line that best fits.
Yes, a line that best fits the data. A line that best represents all of the data points. So we're going to cover that today, and we're going to use the graphing calculator, which makes life a whole lot easier for us to do a line of best fit. So it says a scatter plot is a set of points on a grid used to visualize a relationship or possible trend in the data. So often you will have a graph that looks like this. We've got the x variable, whatever it is. We have the y variable, whatever it is. What do you remember about the x and the y in terms of variables, in terms of data? Do you remember that the x is the independent variable? And if x is the independent, then y is the dependent, okay? Most times you're going to get two sets of data, and it means that this is dependent on whatever that is, okay? And most times x will be time, because time doesn't depend on anything. Time is just time, and that's not going to change regardless of what you're doing. So if you have time, years, anything like that, it will be the independent variable. So scatter plot will look something like you've got data that looks scattered. Independent, dependent in bracket. So a scatter plot is a set of points on a grid used to visualize a relationship or possible trend. So if your data is all scattered, but it looks like it's going upwards, it's showing a trend that as x continues, so does y. That's the kind of trend it's showing you. Okay? If the points on the scatter plot seem to follow a linear trend, i.e. they form approximately a line, so if you've got data that sort of looks like this, it's not perfect, but it forms some type of line, there may be a linear relationship between the data, and technology can then be used to determine a graph and graph the equation of the line of best fit. So if we were doing this by paper, we would draw a line that best fits our data, trying to get it in the middle of all of our points. We would calculate the slope. We'd pick 2 points. We'd get our rise and our run. We would continue on to see where it crosses the y-axis, and we would come up with some kind of equation with a slope and a y-intercept. Okay, we're going to let the graphing calculator do the work for us today. A lot easier. Carter, do you have something to add?
Just about rise over the line.
What did you want to add?
When I first heard it, and now it's the...
Probably the best idea. Okay, so example number 1 says the winning times for the men's 20-kilometer biathlon in the Winter Olympics from 1964 to 2010 are shown in the table. So this table continues here. Okay, so we start at 1964, 68, 72, 76, etc. So A says use technology to determine the equation of the line of best fit. So in your data points, you have to first of all figure out which is the dependent and which is the independent variable. Hey, Mr. Way. Sorry. It's okay. Yep.
You're recording?
I am. That's okay. Hi, Mr. Way. All right. So use technology to determine the equation of the line of best fit. So year, is that dependent or independent? It's always going to be your x. So it's what we're going to plug in for x. So the winning time will be my y variable. So get out the graphing calculator. Turn it on. And find your stat button. So the steps will be, we will press stat.
Where's stat?
Right under delete. 2 across from alpha. Then you're going to press edit, or since it's already on edit, you can just press enter. And it's going to bring you to a table of values that looks like L1, L2, L3. If there's anything in there, clear it all out. If there's nothing in there, you're going to start to enter your data. So under L1, you're going to type in 1964. Then if you want, you can go across and type in 80.4. You can continue on with 1968. Charlie, will you grab the door, please? You can look at her.
L1.
L1 is all the years. Thank you, Charlie. L2 is all the winning times. So you can go down and do all the years. You can go one and then across. I don't care. Go do all the downs and then go over to your L2 and do all of them. It's up to you. We're not doing L3 because we only have 2 sets of data. So type in all of your data points. But what?
Is it just going up by 4? Yeah.
It's the year of the Olympics.
No, but it went 92, 94.
I know what happened. What happened here?
There was no summer that year, so we had another winter one. Oh my god, shut up.
Why is,
Yeah, we canceled summer that year. That's what happened.
why is there such a big gap between 98 and 2006?
Good questions.
It was all summers since the
We are talking about Winter Olympics, by the way, right?
When's the next one? Let's see what's next.
Wait, you just... Okay, what do I do now? Do I press graph?
You'll have to wait for everybody.
Can you scroll up, please? Do we have the summer one this year? I'm snowing.
You have all this on your paper, Carter.
I'm terrible.
Not on your A game today.
No.
Okay, so once all your data is entered, you have to get out of that screen by quitting. So second mode, because the little word quit is above mode. So you've entered all your data, and then you get back into your screen. We're not going to actually look at the graph. We're not going to get it to graph, but we are going to get it to figure out our equation. Enter your data and then quit. Stat edit, enter your data and then quit. To get our equation, we're going to press stat again, then calc, then line reg, which is 4.
And enter.
Enter.
Oh, what does this? Mine just says quit and go to thing.
Okay, so you've done something. Try it again.
Go to.
Yeah, see, wants to take you to your
Back to
mistake.
the thing, I press enter and it just...
And then press enter again.
What's this one?
See?
Line reg.
Line.
Yeah.
It's not working.
I lost my purse. Can I give you my scarf?
Phone.
Just go back to
Can we focus, please? So if you've done it properly, you'll end up with a screen that says line reg. It'll say y equals ax plus b. It will give you a and it will give you b. What's a?
682.
No, what is it though? The slope. Yeah, remember y equals mx plus b? So so your equation is y equals negative 0.682x plus 1419.39. That's the equation. This is the answer for A. Because A says what's the equation?
I don't know why.
Way easier. No, that's the equation. What do you mean? Yeah, that's how you do it. Now, B says determine a possible winning time for the event in the 2002 Olympics. How would I do that? I have an equation to calculate it. What's y again? What did y stand for? What did y stand for? The winning time. The question says determine a possible winning time. Y is the winning time. What's x? That's not a highlighter. X is the year. So, determine a possible winning time for the event in the 2002 Olympics. What do I do with 2002?
Put 2002 bracket for the answer.
Yes, substitute it in, exactly. So, y equals negative 0.682 2002 plus 1419.39. I was like freaking doors. Rounded to 2 decimal places. What was the possible winning time? Yep. I got 58.04.
I got 54.
Seconds. Is that reasonable? Is 58.04 reasonable?
No.
So high.
What'd you get?
54.
All right, let me try my math.
54.026.
Yeah.
All right, I'm going with you guys. $54.02. But again, I ask you, is that reasonable?
Yeah.
When you look at the data, if you got like a minute, that wouldn't seem reasonable. Maybe over here, maybe closer to the top, but as the years went on, they got faster, didn't they?
Yeah.
So that sort of fits the data.
Can you scroll back?
All right, try the question on the back. Same deal. Pardon? It's an S. Seconds. I didn't write an S so it doesn't look like a little 5. That's good. All right, moving on to example number 2. It says a city council needs to buy 15,000 liters of liquid de-icer for the coming winter. One supplier provides the following quote. You can get 9 kiloliters for $1.30 per liter, 10 for $1.20, 11, etc. So it says use linear regression to determine the equation of the line of best fit. So in order to calculate our line of best fit, we need to enter our data. So we have to figure out which is the dependent and which is the independent variable. And this one isn't as easy because which one depends on what? I don't have time. Time is my easy go-to. If it's time, like years, that's always my independent. But would you say that the amount of de-icer depends on the price, or the price depends on the amount? So which is my X and which is my Y? Yes, we will say this is my X, the amount, and the price is my Y. So you're going to go through the exact same steps. Enter your data, come up with an equation. Y equals something X and then something. The way that you can clear your entire column is move your cursor on top of L1 or L2 and then press your clear button. It will clear the whole column at once.
Oh my god, this is gonna take forever. What? The B, would you put in 15? Correct.
Yeah. Because they're buying 15 kiloliters. That's why you put. Yeah, because. No. Just what do you get? Like, what would Y be? What would you pay per?
Yeah, the B was B 15 in for actual.
No, B is 0.064. And then C is, go ahead and calculate it.
I don't get it after you fill in the data what to do.
After you fill in the data, go stat. Right there. Go over to calc. Go down to line reg number 4.
Yeah.
Press enter.
Yeah.
And then see how it says line reg bracket AX plus B? Enter one more time.
Press enter
It was the
Enter twice, yes.
Okay.
I was like, what's that?
So, my equation. If you've done it properly, A should be negative 0.064. Round it off. Your B is about 1.86. Round it off. So my equation is Y equals negative 0.064x plus 1.86. Yeah. So B says, what price should the city expect to pay per liter? Someone's at my door again. Just come in. Come in. So they should expect to pay 0.064 per liter. Last question. What price will be paid in all? Well, the original question, kids, can I finish, please? The original question said we need to buy 15,000 liters or 15 kiloliters. So I'm going to use the equation y equals negative 0.064. Plug in your 15 because it's kiloliters plus 1.86.
Can't you just type about 15 or 15,000 liters and you know how much 1 liter is?
What do you got?
960.
So we should be paying about 90 cents per liter. No kidding. Sad when we're wishing it was 90 cents. No, but it's sad when we wish it was 90. Yes?
Why is it 15?
Because they need to buy 15,000 liters.
So is it 90 cents per liter if they're buying 15,000?
Yes. Yes. Alrighty, your homework. You need a graphing calculator, so unless you have your own, you need to get on task because you cannot take them home.
Why isn't it? Why is it 15 on 15?
It's because all of these ones are all in kiloliters, so that's he could
All right, there's your homework.
Stop somewhere.
Okay, one sec.
Oh, so it's